Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel Chaiken, his brother. We are here to help you approach SAT math questions. This is the last of the non-calculator questions on this particular practice test, and it is a free response. So there's no multiple choice here. It's obviously a word problem. I guess we should start. Please read and then stop and then come back. The mesosphere is the layer of Earth's atmosphere between these two things above the Earth's surface. At the lower distance, the temperature is -5. At the higher distance, it's lower. For every additional 10 kilometers from the Earth's surface, the temperature in the mesosphere decreases by k degrees Celsius. What k is the constant? What's the value of k? Well, isn't that just the slope? We can draw a little picture. Up here at 80, it's -10. And down here at 50, it's -5.
Yeah.
And they're asking for every additional 10 kilometers. So we're going to need a 10 in the denominator. What is the change in temperature? For every 10, there's a 30-degree change here, right?
Yeah.
And there's a what? There's a negative. Oh, this is
No.
-8.
No.
This
is 50. The temperature is 5.
Yeah,
minus 5.
Right. At
At 80, temperature is -80.
Oh, they trick you up to -80, right? So the change is 30. And this is -80.
So the change here is
-75.
30.
Yeah, 30.
So the change here
is 30 over 75.
Delta altitude is 30.
It's 30, and then
the change in temperature is delta T
-75
equals 75.
-75.
So the way good for all this math. But what I simply think, in 30 kilometers it changes by 75.
Right, of course.
How much does it change in 10 kilometers?
Right. So it's
10 kilometers, 10 km, equals 1/3 of 30 km.
Right.
So we take answer equals 1/3 of 75 degrees, which is 25.
Right.
Equal k.
Exactly.
So
that's right.
I would not think of it as a slope.
Okay.
I think of it as a rate of change.
But rate of change
and as a problem where there's something changing, the rate of change is constant, which is only physically approximate, and the deal is constant rate of change. You have proportions. If you change certain amounts in 30, then how much you change in 10 is 1/3 of it.
Right. Yeah.
So you take 1/3 of the change. It's 1/3 of 75. It's particularly easy to do the arithmetic because 75 is a pretty common number. It's 3 times 25. 75 equals 3 times 25, right?
Right.
And so 1/3 of 75 is 25.
Right. So then the only
so I wouldn't bother drawing. This might help our audience to see a picture of what slope means. But I don't know. My line of thinking is not to bother with plotting geometry or equations, but just think of constant rates.
Okay. Yeah. That's fine. Either way, I mean, it's personal choice. It doesn't.
Yeah.
But
I think when you do a problem on the paper SAT, I think it would be a good idea to use your pencil and circle the relevant numbers.
Yeah.
Like I did here.
Right.
50 kilometers is the altitude at which it's -5. 80 kilometers is the altitude at which it's -80. The change in then you need to, it helps you just imagine that as you go to higher and higher absolute values of negative numbers, you decrease. The question is, how much do you decrease? Well, I just think of it in terms of, well, what's happening is as you get to higher and higher altitudes, you're decreasing. I didn't even think of the sign. I just think, okay, the difference between a -5 and an 80 is the absolute value. This is 75. This difference is 30, and the appropriate answer will be positive. So I take just 1/3 of the positive number 75 and get 25.
Okay. So yeah. I mean that's great. Yeah. I mean, yeah. But yeah. That's just the way to do it. Yeah. You see that if it's a change of 75 over 30, then it's a change of 15. No, it's a change of 25 over 10.
Yeah.
Now the thing is the answer positive or negative? At first, I thought the answer is negative, but it actually is positive, because they're saying it decreases by k degrees. See the word
Yeah.
decreases by k degrees.
Yeah.
Because it says decreases by k degrees, you have to make sure that the answer is positive. It is
Yeah.
a positive decrease, not a negative
Yeah.
decrease. Okay, so be careful of
A
that.
negative decrease would be an increase.
Right, exactly. So that's what you do at the very end of the problem. At least that's what I do. Okay, what I do at the very end of the problem is I make sure the algebraic sign is correct. If you go back in the video, you'll see that I said the answer is -25. But before I finalized the problem, I would have checked that, because
Well,
you gotta make sure.
I did the reverse. I thought of what the sign of the answer should be at first.
Oh, okay.
I realized the answer the answer is positive, and so I simply took the ratios, ignoring the signs, and then gave a positive answer.
Right.
The one thing that may be if the trick about is that the two temperatures are both negative.
Yeah.
Okay, they're both negative, and so the difference, the absolute value, the difference is found the same way, whether they're negative or positive. It is the numerical difference, 80 -5 is the difference.
Yeah.
Please, if you people learn this from the number line. Here's 0, here's -5, and -80 is over here. -80 is less than -5, but the difference is 75.
Right.
Okay.
They could have easily have made the temperature up here 15, and then the difference would have been 95.
Yeah.
Positive 15.
Oh, okay. Yeah. Right. If you're on the this is 70. If the black situation is a different situation. There's 0. If this happens to be +15.
Yeah, right. Yeah.
And then we have a point here, which is -80. The difference is composed of this amount plus this amount plus this amount. So we get 15 plus
80.
Plus 80. 80 plus 15.
That makes 95.
is 95 is the difference between minus 80
Right, we know. So, we don't have to say it 3 times. We know.
minus
Got it.
a minus a plus
Yeah.
15.
Right. So
Alpha
just
value.
be careful. Just use, it's helpful to draw number lines or temperature scales like these. And then you really see what's going on as opposed to doing this subtraction of negative numbers. Could be confusing. Could be confusing.
Yeah, well, those rules about subtracting negative numbers, those rules are not they're not just made up. They come from how space and lengths of space are organized on the number line.
Right. That's right. That's right. So that's why it's maybe safer in problems like these, where usually the numbers are really clear, to think of a number line rather than think of the formulas.
Yeah.
It's a little safer. And this is question 20. This is the end of the non-calculator section, so your brain's probably a little tired by now. Okay. So I guess that's it. And there are probably other ways to view this problem too, but there are 2 ways of them: the slope or the waste, the direct proportion. And remember, slope is equal to rate, and rates are equal to slopes. Okay, that's it, right?
Right.
Yeah, okay. Have a great day. Please like us, dislike us, give us comments, send us your SAT math questions to satmathquestionoftheday@gmail.com. Tomorrow is Throwback Thursday, something we can all look forward to. Okay, bye-bye.